Hi, this is just a brief review about how to determine the number and types of solutions when you're dealing with a quadratic function. So, for example, a quadratic function may look something like this, and we have learned in class that this is a quadratic function in vertex form. When a quadratic function is in vertex form, a graph is a very easy way to determine the number and type of solutions. What we learned about graphing is that our parabola has been shifted to the right, 3, and that our parabola has been shifted down, 2, and that our parabola is opening concave down if this is negative. So just kind of in a general sketch, again, right 3, down 4, and it's a parabola opening down. And what that tells us is we have no x-intercepts. So there are no x-intercepts. What that means is there are imaginary solutions. There are no x-intercepts. So we have, and it turns out that every time you have imaginary, you have 2 imaginary solutions. So a graph can tell you that picture. So if you remember all of your shifting and up and downs from last chapter, that will determine the number and type of solutions. If you are given an equation that is in standard form, something that looks like this, and you are unable to quickly make a graph, you don't have a graphing calculator, you don't know how to do it, the other way that we talked about determining the number and types of solutions was to look at something that was called the determinant, or the discriminant. The discriminant is just the part of the quadratic formula that's under the square root. It's that b squared minus 4ac. It's the part that determines if you're going to pop an I out or not. And that's really important because if your discriminant, your b squared minus 4ac, if it's positive, then you don't need to pop an I out, and positive implies that you will have 2 real solutions. If the discriminant is negative, again that's the part underneath the square root, if it's negative, you will have to pop an I out, so you once again get 2 imaginary solutions. And if the case comes that you have your discriminant and it actually equals 0, that means you will have 1 real solution, but it's called a double root because if you add 0 and subtract 0, you get the same exact answer. So if you get a discriminant that's 0, you have 1 real solution, and it's called a double root. So if we look at this example we have, again, looking for the discriminant, b squared minus 4ac, that would be 5 squared minus 4 times 1 times negative 2. So that would be 25 minus 4 times a negative 2 would be a positive 8. And so our discriminant is actually a positive 33. And we said if it was positive, there would be 2 real solutions. So I don't have to solve this problem. I just know that there are going to be 2 real solutions because when I square root, I get that exact value.